So this chapter is all about testing different models for predicting the expected returns on a stock. What we're going to do is we're going to think back to what we know about basic finance. So the first thing you learn about predicting the expected rates of return on a stock is higher risk requires a higher reward. Okay, so then the question is, how do we measure risk? And we start with talking about measuring risk relative to, using variance. And then we talked about the fact that people don't hold just one stock. They end up holding a portfolio of stocks. And when you do that, the covariance between different assets causes the risk to decrease overall as when we find assets that inversely covary. And then we said, okay, well, if that happens, then let's assume that we have a broad market portfolio that we're holding, in which case we are only susceptible to market risk because as we increase the number of assets in our portfolio, we diversify away the unique or firm-specific risk, and we're only left with market risk. And this is the logic behind CAPM. It says, remember the intercept in the CAPM model is the risk-free rate of return because it says, no one's going to invest in anything and earn less than the risk-free rate of return. If I'm bearing any risk, I must earn at least the risk-free rate of return. So that makes sense as to why the CAPM predicts that the y-intercept would be the risk-free rate of return. And then you're going to have a market risk premium, which is going to be encapsulated by beta. So how sensitive is your stock to changes in the market? We say, that's our beta coefficient, our covariance of our stock with changes in the market, and we're going to multiply that by RM minus RF, which is the market risk premium, the amount that we earn above the risk-free rate of return, and then plus any kind of error term when we're doing this using actual data. So that's what we learned, that's what you knew before you started this class. And then we showed you CAPM, and then we showed you how CAPM is applied. Then we said, all right, well, CAPM, that's our theory. Let's see if there's any other models that might work. So then we discussed APT. CAPM was one version of APT where there's only one factor that matters, and then other multi-factor models where we start to price in other factors that might have an impact that might, so the argument there was that some risks were not fully incorporated by that market portfolio. There are still other things that impact stocks. So then we went on in chapters 11 and 12, and we looked at different things that might not be priced in. So that's why we started looking at behavioral things. That's why we started looking at technical things. And that's why we discussed in one of the chapters, he talks about the fact that what do most portfolio managers use? They use a four-factor Fama-French model, which is the three regular factors in Fama-French, so SMB and HML, plus the market portfolio and the risk-free rate of return, and then also a momentum factor. So in this chapter, what we're doing, we're showing how all of this ties together. So we're looking back over a history of different mathematical models to try to figure out what is the best way to predict what our stock price should be. And this is an evolving field. So one model will come up, it'll predominate, it'll proliferate, we'll hear about it. CAPM was the first one that really came out, so the early tests focus only on CAPM. Then as the market anomalies started to trickle through, as we started to see that more in the literature, we start to see models that are, incorporate those market anomalies. Then the fundamentalists will come back and say, oh, well, that doesn't really matter. Once we know about it, we can exploit it, and that should disappear. So then you'll do another series of tests to see, does that actually work? And this is what's going on consistently in the academic literature. So some of the, this is the papers that you are going to be presenting. So we start out first with just examining CAPM. All right, so CAPM is our theory, right? And our single index model was basically our application of CAPM. So what did you do? You estimate the beta coefficient and the alpha. Now, if CAPM really holds, there is no alpha. The intercept would just be that risk-free rate of return. But notice when you were estimating those beta coefficients, you used excess return above the market, so RM minus RF. So you were always calculating with those market risk premiums. Sorry about that. All right, so that's how the tests of CAPM work. They're basically just tests of the single index model and saying, are the alpha values really equal to 0 over time? So the way that they do this is going to be in two passes, a first regression and a second regression. So what they'll do is they'll collect a series of information about the risk-free rate of return, the return on a market portfolio. So there's been a variety of different tests using a variety of different quote-unquote market portfolios. Most commonly, it's the S&P 500. And the first pass regression, what they will do is they will estimate the beta. So they will regress your stock's return on the market's rate of return. So X, your independent variable, will be the stock's rate, the market's rate of return, and then Y, your dependent variable, would be the your stock's rate of return. So X is market, Y is your stock, because your stock depends on changes in the market. And from that, they get the beta coefficient. That's what happens in the first pass regression. Then in the second pass, you use those betas that you got from the first pass, and you go ahead and you estimate what actual returns will be, and you compare them. So step one, gather data about your stock and the market. Then plug that into a regression to estimate your beta coefficients. Okay. Step two, use a new time period's worth of data. So they'll break these into, I'll do 5 years worth of data and then I'll test it on the next 5 years, or I'll do 10 years worth of data, I test it on the next 10 years. There's been a series of different papers. All of them have used different time periods. They've argued that it works better in some time periods, worse in others, but that's the general idea. So now I have all my beta coefficients. Then in the second pass regression, what I would do is say, all right, here's my rate of return on the market. Here's my beta. I'll basically just plug into CAPM and see what is the predicted rate of return. So what does this model spit out as my predicted rate of return? And then I will compare my predicted rate of return with my actual rate of return to see, did CAPM work, or did that single index factor actually work? So there's a series of different tests on this. I think some of you are presenting them. Your textbook has a list of all of the different authors that have gone through and published papers on this. But in general, the results are that the security market line, remember that's what our CAPM equation, that's the graph that it gives us, that gives you return relative to beta. The slope is too flat, meaning that the beta doesn't fully encapsulate how your stock reacts to changes in the market, and the intercept is too high, meaning that the intercept isn't really the risk-free rate of return. So the arguments here, well, they're saying, well, so that would mean that CAPM doesn't really work, because beta doesn't fully incorporate all of the risk measures that our stock is facing, and the intercept isn't in fact the risk-free rate of return. The intercept on average is higher than it would be if the intercept, if we were following CAPM and the intercept was that risk-free rate of return. So, okay, well, you're like, well, that sucks. Then why am I still using CAPM? Well, many papers have examined this, and overall, they'll say, yeah, there are issues with it, but expected returns on average are linear and do increase with beta as a measure of systematic risk, meaning beta does work. It might not work perfectly, but it does work, and there is a linear relationship. So let's not throw away beta entirely. And expected returns are not affected by non-systematic risk, meaning that overall, once you have a diversified portfolio, you can just use beta. So the results of the early tests, and the literature goes back and forth, but overall, the results of the early tests are it's not perfect, but it's not total crap, so let's not scrap it. There is still some benefit to CAPM. So I think someone is presenting Roll's critique, and Roll is like, all right, listen here. He goes back and they look over all of the material that's been done in this area and they say, all right, now the reason that you're finding all of this is because CAPM is a theory. Remember, we talked about all the assumptions that go into CAPM in Chapter 9, right? You have perfectly efficient markets. Everyone can borrow and lend at the risk-free rate. Everyone is a price taker. You know, this is an economic model. In other words, it's not real life, right? So the only thing that we're really testing when we test CAPM in this way is if the market portfolio that you're using, the S&P 500 or whatever you're using to proxy for this hypothetical theoretical market, all you're really testing is if that truly represents the market and if that is mean variance efficient. And if that's not, because you don't know if that's true or not, then CAPM itself isn't really testable unless we know the exact composition of the true market portfolio and use it for our tests. In other words, okay, you can keep testing all you want, but until we come up with this full market index and we're 100% positive that that represents the full market, we can't ever know if CAPM is really real or not. So Roll's critique says, yeah, keep testing all you want, but you're not really testing CAPM. And we haven't really come up with a way to test CAPM because until we know what that market is, we can't.